Okay, think about this. What is a binomial? A binomial are two terms that are being added together. A plus B, okay? Two terms being added together. Well, what if you have two terms like A plus B raised to a power? How do we expand A plus B raised to a power? Well, you better be careful because it's not an easy process and people get lazy and they just try to distribute the exponent to each of the terms that are being added together, and that is so illegal. That is so wrong. No, you can't do that. You have to actually take the base, which is A plus B, and multiply it by itself repetitively the same quantity of times as the power, the exponent. Okay, so let's take a look at this idea. What if you had a binomial A plus B and you raised it to, say, the 0 power? What would that answer be? Well, that's easy. Anything raised to the 0 power here in our algebra class is equal to 1. But what if we took A plus B and we raised it to the next highest power? The next one would be 1. Well, if you raise anything to the first power, it's just itself. So it's just A plus B. Okay, what if we take the same binomial A plus B and we raise it to the second power? Okay, things are getting weird here. We'll have to use A plus B parenthesis times itself parenthesis A plus B, and we'll have to distribute the multiplication. We'll use FOIL or some trick like that to get first times first is A squared plus AB gives us 2AB in the middle, plus the B times B is B squared at the end. Okay, now things are getting tough. A plus B to the third power. How do we get that? Well, we're going to have to do A plus B parenthesis times A plus B parenthesis times A plus B. We'll have to FOIL the first two, then distribute the last factor of A plus B. It's going to take about half a page, and when we finally get it, we'll simplify by combining like terms. We get A cubed plus 3A squared B plus 3AB squared plus B cubed. That's the answer. Now, it'll take you a few minutes to get it, but that is what you'll get. Now, it's getting hard. I don't want to keep doing this, but you get the idea. I'm coming up with these different binomial expansions. In other words, I'm expanding the sum of two terms raised to the 0 power, the first power, the second power, the third power. And we're getting this strange triangularly shaped thing that has on the left diagonal, it has 1, A squared, A cubed. It has 1, B squared, and B cubed, etc., etc. Now, so the pattern that we have on the A's is pretty clear, and our B's. And even if we go horizontally across each row, we can actually see what the patterns are on the A's and B's. Let's take, for instance, A plus B to the third power. Let's just look at the A's. We start with A to the third power. That power matches the power on A plus B. So it's A to the third power. The next term that we're adding, ignore the coefficient 3. The next term has A 1 power lower, A to the second. The next term has A to the first, 1 power lower. And the last one has A to the 0. That's why you don't even see it. Now, what's happening to the powers of B? At the beginning where you have A cubed, that's multiplying B to the 0 power, guys, because B to the 0 power is just 1. That's why you don't see it there. So we start with the first term having B to the 0 power. The second term has B to the first power. The next term has B to the second power. See, the exponent keeps going up by 1 increment. And the last term has B to the third power. So we stop when we get to the power 3, which is the power that we have on our base A plus B. So you can see the pattern. The powers of A, the first term in the parenthesis, are starting with the third power and going all the way down to the power 0. While the powers of B are starting with the 0 power and doing the opposite. They're going up to finally to the power of the exponent 3. Okay, so that's pretty cool. I mean, it's easy to see what those patterns are with A's and B's, but what we do not understand here is what the heck is going on with the coefficients. Where are those numbers coming from, 3 and 2? I mean, what kind of pattern is there? If we just totally don't write the A's and B's and just write the coefficients, we will be able to take a look and see what the coefficients are for each row. The 0 row, where we go to the 0 power, it has just a 1. And then the A plus B, that's 1, and then a 1. And then we have a 1, 2, and 1, a 1, 3, 3, 1, etc. So the question is, now, do you see that? Before I ask you the question, you see that those are the coefficients in each row. The n equals 0 row just has a 1. The n equals 1 row has a 1 and then a 1. The n equal 2 row has a 1, a 2, and a 1. The n equal 3 row, the power 3 on the binomial, has a 1, a 3, and a 1. So what pattern do we see here? How are we getting these numbers and what kind of pattern? Now you can pause the video for the answer and then come back and see if you get it. We have 1 and then 1, 1, If we add the two ones together, we get 2. 1, 2, 1. We have ones on the outside, and the numbers on the inside are formed by adding the two numbers on the diagonally above it. So the ones on the outside and the sums of the two numbers above it on the inside of this Christmas tree, I call it. It's really a triangle.